We will now proceed to the gas chromatography. So gas chromatography is also known as the gas liquid chromatography. This is a process wherein it separates components from the given crude drugs by using a gaseous mobile phase. So this involves a sample being vaporized and ejected into the head of the chromatography column. The sample in here is transported through the column by the flow of inert gaseous mobile phase. After that, the column itself contains a liquid stationary phase which is adsorbed onto the surface of an inert solid. So as you can see in the picture, these are the parts of the gas chromatography. The first one is the flow controller. The function of this is it automatically controls the flow rate of the gas according sa set flow rate na nasisend as an electric signal. Next is the carrier gas, which is ang function naman nito is to provide the gas that will be used as a mobile phase for the gas chromatography separation. Ang injector port naman is used to control the electronically to atomize fuel under the high pressure into an engine's combustor chamber. The column, ang column oven, this is the one that controls the column temperature from to room temperature. And ang detector, syempre to detect components of the mixture being eluted off the chromatography column. And lastly, a recorder to record the response obtained from the detector. So, generally, ang ginagamit dito na recorder talaga is the potentiometric detector. So, in this type of recorder, the input response is continuously balanced by feedback response. More from gas chromatography, this is separation of gaseous and volatile substances. So this is actually consists of two, the gas-solid chromatography and the gas-liquid chromatography. Ang principle ng gas-solid chromatography is adsorption, whereas ang principle ng gas-liquid chromatography is departition. So as you have noticed, kanina diba I mentioned na gas chromatography is also called as the gas-liquid chromatography. So bakit hindi gas-solid chromatography? Hindi ginagamit talaga ang gas-solid chromatography because limited lang ang number ng mga stationary phase. So ang ma-considered na stationary phase dito sa gas chromatography is gas and liquid, whereas ang mobile phase nila or the element is yung mga gas na such as the hydrogen, helium, and nitrogen. To add more from the two major types of the gas chromatography, ang gas-solid chromatography, here, ang mobile phase niya is gas, while the stationary phase is solid. This is used for the separation of mga low molecular gases such as the air components na hydrogen, sulfur, carbon dioxide, rare gases, carbon dioxide, and oxides of the nitrogen. Whereas ang gas-liquid chromatography naman, ang mobile phase nila is same, the gas, while the stationary phase is a liquid retained on the surface as an inert solid by adsorption or chemical bonding. So, madali lang siyang alalahanin since ang gas-solid chromatography, gas and ang stationary phase niya is solid. Tapos sa gas-liquid naman, ang the same as true na mobile phase is gas, tapos ang stationary phase niya is liquid. For the history of the gas chromatography naman, the father of modern gas chromatography is actually a Nobel Prize winner, which is John Porter Martin, who also developed the first liquid gas chromatograph during 1950s. This is good for volatile samples up to about 250 degrees Celsius, and it can detect about less than 1 parts per million with certain detectors and can be easily automated for injection and data analysis. We will now proceed to the general types of the columns, which are the packed columns and the capillary columns. So as you can see in the picture, they are densely packed with finely divided inner solid support material coated with liquid stationary phase. Tapos sa gas solid naman, the columns are packed with adsorbents or porous polymers. So in terms of the length, the packed columns length is about 1.5 to 10 meters. Ang internal diameter is 2 to 4 millimeters. Tapos sa capillary columns, ang length is 10 to 100 meters. Tapos ang internal diameter is 0.1 to 0.5 millimeters. So in terms of the length, mas mataas or mas malaki ang capillary columns, tapos in terms of the internal diameter naman, mas malaki ang packed columns. How does gas chromatography work? So, para mas madaling maintindihan, there are 3 steps lang to follow. So, the first one is that a vapor sample is injected into the chromatography column. So, as you can see in the picture, ito yung sample, yung color yellow, magpasok dito sa injector, and after that, dito na sa oven. So, dito sa oven, the sample will move through the column through the flow of inert gas. And after that, mag-detect siya dito, i-detect yung mga substances, and kapag okay na, the third step will be the components are recorded as a sequence of peaks as they leave the column. So, dito. So, bale, in short, sample will enter, tapos dito, sample will move through the column or the oven, and mag-detect siya, and after that, i-record na yung mga na-detect na substance. Since this is a gas chromatography, therefore, ang mga ginagamit na substances dito is also gas. Some of the gases that are commonly used are the hydrogen, helium, nitrogen, and carbon dioxide. So, ang hydrogen is used because it has a low density and better thermal conductivity. However, it reacts with some unsaturated compounds and is inflammable and explosive in nature. Tapos, ang nitrogen naman is inexpensive siya, but it gives reduced sensitivity. Therefore, helium is the most preferred gas, pero medyo mahal lang siya. In terms naman of the substance assay, the following are being assayed, such as the fatty acids, the terpenes, the flavors, and the esters. Lastly, for the advantages of this, it has a very good separation for the time. In terms of time naman, the analysis is short and small sample is needed lang. And other than that, may good detection system din siya. And lastly, it is the sample being acid or quantitatively analyzed.